Okay, so the purpose of this video is to look at hypothesis testing about a single mean using a similar example I've been using in several videos, right? I've recently been considering tutoring students individually. It's been a while since I've done individual tutoring. Not sure how much I can charge. Okay, so I'm hoping I can get at least $75 an hour, to be honest with you. And so I'm doing a data collection to determine, what are people paying, what are people charging? Can I get $75? So I've decided I'm going to survey parents of school-age children to see how much they'd be willing to pay for math tutoring. I surveyed 72 students. The mean amount that they indicated they would be willing to pay for private tutoring is $68 with a standard deviation of 12. Okay, a little discouraged. So I had a conversation with a colleague of mine, and I mentioned to this colleague that I thought that the mean amount that parents would be willing to pay would be at least $75. She argued instead that the mean amount that parents are willing to pay for tutoring is actually going to be less than $75. So I'm testing her claim to see if it's reasonable to conclude that the average amount that people are willing to pay is in fact less than $75 an hour. And I'm going to test this at a 5% significance level. Okay, the process in the calculator is fairly simple. I'm going to go to Stat, Tests, okay, and it's going to be either a z-test or a t-test since I'm testing about a mean, okay. And the calculator does a good job with option 5 or 6 saying this is a 1 proportion or a 2 proportion. It doesn't say this is a test of means, it just says it's a z-test or a t-test. Remember that the z-test is used if you know sigma, the population standard deviation. In this case, we don't. All we know is the sample standard deviation of 12. So I'm going to use number 2, the t-test. I don't have the actual data here. I have my stats. Notice if I had the data, it would ask me what list my data is contained in, and I would have put my data in that list, and I would simply tell the calculator it's in list 1, list 2. I did a test here with my data in list 3. So instead what we have is the stats. And so my hypothesized mean, my null hypothesis is $75. I found a sample mean from the sample that I took, from the survey I took. I found a sample mean of $68 with a standard deviation of 12, okay? And I surveyed 72 parents. And now here, I'm gonna set whether my alternate hypothesis, am I testing to see if mu is actually different from 75, less than 75, or greater than 75? As I mentioned in the middle paragraph to the left, my colleague argued that the mean amount is actually less than 75, and so I'm going to set this to mu is less than mu sub 0 or less than the 75. I go down to calculate. I'm going to press calculate, and the calculator runs this very quickly. Okay, t is negative 4.95, which is huge. My p-value, remember, is not 2.414. My p-value says it's 2.414864 e negative 6. And remember that e negative 6 is scientific notation. So my p-value is really 0.000024. That's 5 zeros before you get to the 2. So my p-value, therefore, is 0.000. Notice that the x bar, sx, and n are repeated to give us that information back. So since my p-value is less than 0.05, I would reject my null hypothesis that the mean is at least 75, and I can reasonably conclude here that the mean is actually less than 75. So just a very quick, let's look at the 95% confidence interval. So my colleague says that the mean is actually less than 75. Okay, well then what is it? To do that 95% confidence interval, remember we go back to stat, tests, and now in this case we would pick, if we used number 2 before, we would use number 8 this time. So 8 would be the t interval, so I select number 8, and notice I can just press the number 8, and the data is there. X bar was 68, sigma was 12, n is 72. My confidence level will change that to a 0.95, and my confidence interval, notice, is 65.18, 70.82. So based on this data, I would conclude that the mean amount that people are willing to pay for private tutoring is somewhere between, I'm going to call it $65 and $71 an hour. Okay, so there's a quick look at hypothesis test along with the confidence interval using the TI graphing calculator.